Hi guys, so we're going to talk about the Geometry Common Core exam from August 2016. Hopefully I will be able to guide you through some questions that you're maybe unsure about, or if you recently took this exam that you wanted to see how you did on. So this is my answer key. Use a little blue pen here. Answer key. Don't mind my handwriting, I'm getting used to this pen here. Alrighty, so lines A, E, and BD are tangent to circle O and P at A, E, B, and D is shown in the diagram below. If A to C is proportional to CE in the ratio of 5:3 and B to D is 56, determine and state the length of CD. Okay, so we know that B to D is 56. So I know if I call this X, my favorite letter is X, right? Then this is whatever's left over. So that if X is 2, it's 56 minus 2. So 56 minus X is what I'm going to call B to C. Then I know that my pieces are in a ratio of, let's say, 5y to 3y. That's just their ratio. So I'm going to go down here and I'm going to set up a proportion. Let's see. I'm going to do 5 over 3 is equal to the bigger piece, which would be 56 minus x, looks bigger, over little x. And then you're just ready for your cross multiplying. So 5 times x is 5x equals 3 parentheses 56 minus x. Let's make sure I'm not losing it here. Okay, so 5x equals, distribute your 3. 56 times 3 is 168 minus 3x. So I want to get my x's together. I'm going to add the 3x over and get 8x is equal to 168. And then I just have to divide by 8. Now, I want to make sure I go back and read the question. X is 21. And it says, determine and state the length of CD. Well, C to D I called X, so actually C to D is equal to 21. So C to D is equal to 21. Excellent. Moving on. So I'm going to go to the next question, which would be pretty easy. This one should have been all right. In the diagram below, triangle ABC has coordinates 1, 1, 4, 1, 4, 5. Graph and label the A double prime, B double prime, C double prime, the image of ABC after the translation 5 units to the right and up 2 units, followed by a reflection through the line y equals 0. I'm going to tell you a secret. If you made a mistake on this question, it was probably this. Either that or you miscounted. Y equals 0 is the x-axis. It is not the y-axis. So that's where a lot of people made a mistake. You would only earn 1 point if you did that. So the first thing I'm going to do is translate 5 units to the right and 2 units up. So I'm going to start with A. 1, 2, 3, 4, 5, up 2. There's A prime. B, 1, 2, 3, 4, 5, 1, 2, B prime, and C, 1, 2, 3, 4, 5, 1, 2, C prime, to the best of my, now you had a straight edge, so yours should be perfect looking. I do not, so sorry about that. Now we want to reflect over the x-axis. So I'm going to change colors, and I have 3 units to the x-axis, so 3 units over, A double prime, 3 units to the x, 3 units over, B double prime, and C is, let's see, 4, 7, so 3, 4, 5, 6, 7 units to the x-axis, 7 units over, and connect your triangle to the best of your ability. Okay, make sure it's labeled. That's kind of a big deal for your life. Let's do one more before I cut this video. Okay. Number 27 was actually pretty easy if you were thinking about it. So Let me get rid of this triangle. Some things are lingering here. A regular hexagon is rotated counterclockwise direction about its center. Determine and state the minimum number of degrees in the rotation such that the hexagon will coincide with itself. Key thing here is that a regular hexagon means that all sides are congruent. So, oh, I don't have the shape in here. Sorry, I thought I did. So a hexagon, first of all, has 6 sides. 6 sides. And we're rotating counterclockwise, so that is this direction. So if I just sketch one of these things, clearly I'm doing a great job. I'm sorry about this side. That is 6 sides, center of rotation. I am turning 1/6 of a full turn. And a full turn in my brain is 360 degrees. Divided by 6, I am turning it 60 degrees. That's all you had to write down. 360 over 6 equals 60. Uh, 28 is a construction, so I'm going to do my best to walk you through it. Clearly I don't have a compass and a straight edge on the computer here, so I'm going to kind of walk you through the idea. It says that the diagram of triangle ABC, please construct a median to AB. You have to know that the definition of median, okay, median is the middle of the side connected to the opposite angle or a vertex, okay? So what I saw a lot of people do, most of you did this right. You essentially did the perpendicular bisector of AB, which is perfect, but then you didn't connect it to vertex C, so that wasn't very good. So if I had a compass and a straight edge, I would pick a distance a little bit more than halfway between A and B, and I would make an arc above and below from A. That same distance, remember that distance or keep that distance, and go from B, put your center on B, and make an arc above and below. And then you would connect using your straight edge those two. And this is your midpoint, right? Because that's the perpendicular bisector. And then you would just connect that to C with your straight edge. And this is your median. Yeah? Looks good? Thanks. All right, moving on to the next question. Triangle MNP is the image of triangle JKL after a rotation of 120 degrees about point Q. If the measure of angle L is 47 degrees and the measure of angle N is 57 degrees, determine the measure of angle M. Explain how you arrived at your answer. So the first thing I would start to do here is just label. L is 47 degrees. And N is 57, okay? Now, what do you know? You know it turned, but did that change the triangles at all? No, because rotations are congruence transformations. So here's what you did. You say out loud on your paper, a rotation is a congruence transformation therefore the measure of angle, and I've got to see my triangle things up here. Let's see. N matches with J, or M matches with J. Measure of angle M is equal to the measure of angle J. The measure of angle N is equal to the measure of angle K. And the measure of angle P is equal to the measure of angle L. Yeah? Is that right? Okay. So that means, let's see, N and K are the same, so this is 57. and L and P are the same, so this is 47. Okay, so in a triangle, there are 180 degrees. So the measure of angle M is equal to 180 minus 57 minus 47, which is 76 degrees. Just explaining that. So you had to say something about it being a congruence transformation, and then say something about the total number of degrees in a triangle being 180. Those are two things I think every geometry student knows or can learn very easily, okay? So let's go on to page 16. What is this one? Okay. A circle has a center at 1, -2 and a radius of 4. Does this point lie in the circle? Justify your answer. Okay. A lot of people tried to use their graph paper. They did okay. What you wanted to do here was write the equation of a circle. If you have a center and a radius, you should be able to come up with the circle equation. I'm going to write the general form. First, it's x minus h squared plus y minus k squared equals the radius squared. And the center is h comma k, where we change the signs. Okay, that's just a fun fact for you. So in this one, when the center is 1, -2, I say that it's x, change the sign, minus 1 squared plus y, and then this is minus 2, so I'm going to put plus 2 inside the parentheses, squared equals 4 squared is 16. Okay, so there's my equation of my circle. You probably could earn a solid point for that. Now, in order to decide if that point is on the circle, what this is giving you in math code, and I've said it already once during this test, is it's giving you an x coordinate and a y coordinate. If you plug in for x and y, and that's a true statement, then that point is on the circle because the equation is true. So I have to go in here and say, okay, 3.4 minus 1 squared plus 1.2 plus 2 squared equals 16. So I need to go to my calculator for sure, right? And I need to type all of that in. I can't see it, so 3.4. Oh dear. I apologize. I just did something crazy. I'm going to have to get the Krausenator down here probably. Okay, so parenthesis 3.4 minus 1 squared plus 1.2 plus 2 squared. And I should get 16. Yep, I did. So let's go here. Let's go like this. Oh, good. I did a good job. Okay. So I got to get this. Oh, got to go right side up now. Sorry, guys. I'm having a hard time. This got me 16 equals 16. So since that's true, I can say that it lies on the circle. So yes, the point satisfies the equation. Yay. Okay. Let's maybe do one more here. Oh, beautiful. Beautiful trigonometry. Oh, so beautiful. Let's see if I can zoom this little guy in a little bit better. Can I? Nope, I'm having a problem. I am not having a good day with this little guy, am I? Let's try this. Okay. Anywho, maybe this will work. Maybe not. I don't know. In the diagram below, a window of a house is 15 feet above the ground. A ladder is placed against the house with its base at an angle of 75 degrees with the ground. Determine and state the length of the ladder to the nearest tenth of a foot. I'm going to go ahead and call that x because I'm going to guess that's what you probably called it. So I am standing at the base of this. I always like to draw a picture of myself here. And I know the side opposite, and I want to know the hypotenuse. So I like to write down right at the top of my paper, SOHCAHTOA. Some old horse caught another horse, taking oats away. I don't know how you remember it. I just remember it as SOHCAHTOA. So as soon as I see opposite and hypotenuse, I know that I'm dealing with the first part. So that means sine. Sine of the angle. The angle always goes with it. So 75 degrees is equal to opposite over hypotenuse. Okay? So, oh my goodness. Well, your favorite thing to do in the whole wide world is cross multiply. So I have x times the sine of 75. Now the sine of 75 is really some crazy number. I could put it in my calculator right now, but I'm not gonna. Equals 15 times 1, which is 15. I've got to get x alone, and instead of writing out a crazy number here, leaving it as sine 75 is actually easier to write. So I'm going to divide, in order to get x alone, by the sine of 75. And I'm going to actually type that in my calculator. So x is going to be equal to, and now I'm going to round to the nearest tenth too. See these rounding directions? These will literally cost you a bunch of points if you don't pay attention. So pay attention, highlight them, star them. When you go through your test, you should probably notice that there's some rounding directions at the end of the test. You should probably go back and make sure you rounded correctly, or else. Yeah? Got it? Okay, good. So let's go to the calculator. 15 divided by the sine of 75. Doc B. Control divide. 15 divided by, oh, arrow down, sine, enter, 75, enter. 15.529. 15.529. 15.529. Wait, what did it say about rounding? It said round to the nearest tenth. In order to round to the nearest tenth, you look at only the next place. That 2 tells you to stay, not raise. So x equals 15.5, that's a 5, you're welcome, feet. So another construction on number 32, and again, I don't have a straight edge and a compass on the computer, so in order to kind of talk you through this, I'll try to explain it the best I can. What you would want to do is it does say construct and label the image after a dilation with scale factor 2, centered at B, leave all construction marks. So when I think about this, I think about that classic diagram you've seen a bunch of times, and I'm just going to draw it here. You've seen like a triangle, and they say, oh, we've dilated the triangle, and so you know that these two sides are parallel and the two triangles are similar. Okay, you've seen that diagram a million times, but that's what they're having you create. So down here, what you would want to do is you would want to take your compass and you would want to measure from B to A, right? And if you're going to dilate it by a scale factor of 2, you're doubling it in size. So you're going to go from B to A and you're going to measure, and then you're going to go from A and you're going to make an arc over here somewhere, which is the same distance. Then you're going to measure B to C and you're going to double that one, and that's going to be here, right? And then you're going to, connect those. Okay, that's it. You're going to turn that into, so this would be A prime, and this would be C prime, and B is B prime. B isn't moving at all. So now you have, and you're using your straight edge. Clearly mine is not going to be perfect here. So clearly we have a doubled triangle. Okay, now it says describe the relationship between the lengths of AC and A prime C prime. Well, they're parallel. Okay, great. What they want you to say here is that the length of AC, okay, the lengths, relationship between the lengths. So just saying they're parallel isn't about the length. So AC is what in terms of length? It's half of A prime C prime, or A prime C prime is double, right? So you can say it either way. You can say that AC is equal to half of A prime C prime, or you can say A prime C prime is 2 times AC. However you said it was perfectly fine. Okay, page 19. Oops. Okay. So we've got this picture or this grid here. Triangle A prime, B prime, C prime is the image after a rotation about point A. If you didn't read carefully, like me the first time, you did not read that and you had a hard time. Determine and state the location of B prime if the location of C prime is 8, -3. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. Okay. So, oh, what in the bananas just happened? Did you see that? Did you see the ghost of the letter C? No? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. This is, oh my goodness, computer, please play nicely with me. This is C prime. Okay. They're saying we rotated and, get my little thing here. If we rotated and we got this to here, C went to C prime. That seems doable, right? What does that look like a rotation of to you? In my brain, that looks like a rotation of 90 because a rotation of 180 would look like this, 270 would continue here, 360 would be like this, right? It's a quarter of a full turn. So I'm figuring I have to turn this 90 degrees. Oh, bananas. Okay. So B, if you turned your paper and recorded the coordinates, which I did do at some point, and I don't have it written down, so I apologize. But B prime will end up at 7, 1. So 1, 2, 3, 4, 5, 6, 7, 1. Oh my goodness gracious. B prime. You can also do it by saying, if I travel from C to B, I would go up 1 and over 1, 2, 3, 4. So up 1, or over 1, up 1, 2, 3, 4. Does that make sense? The slope. So you could do it that way. That's fine too. And then, so because we're rotating around A doesn't really move. So there's my triangle. Again, killing it with my drawings. Okay, so I have this beautiful picture. Great. What do they want to know? Explain your answer. Determine and state the location of B prime. Okay, so I can say that, let me find where I'm writing here. Sorry. Okay, I can say, yeah. We know, oopsie. Oh my goodness, I am sorry that I'm a disaster here. Okay, we know that it is a rotation of 90 degrees about point A. Based on the location of C, sorry, based on the location on the location of C. Got it. Okay. Since, and I did the slope from B to C, so since the slope from, I did C to B is up 1, what did I say? Up 1 over 4. The slope of C prime B prime, if we go up here I can show you, C prime B prime is up 4 left 1, right? So up 4 left 1 would be the negative reciprocal because we turned it 90 degrees. Wouldn't they be perpendicular? Okay, because negative reciprocal slopes, my writing is just killing me on here. yield perpendicular segments. So B prime is 7, 1. Lovely. Are the triangles congruent? And we've actually had this topic on this test already. It is not a dilation. So a rotation is a congruence transformation. Yes. 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 Triangle DEF is congruent to triangle A prime, B prime, C prime. Oh, not C double prime. C prime. Oh, and I was just thinking about the transformation. We're talking about a DEF is what in relation to A prime, B prime, C prime? It's reflected, right? It's a reflection over, I don't know, 1, 2, 3, 4, 5, 6. So over this line, if you can see it. Yeah. So, yes, the two triangles are congruent since it is a reflection. And I'm going to just say a line reflection, which is a congruence transformation. I apologize for my writing. I will get better as I practice with this, but it's not great today. First time for everything, right? Okay, let's look at the next question. If I can get my Zoom going on here. Loved this question. I'm going to guess that if you didn't know how to start it, you didn't know how to do any of it, which is always really, really tricky for kids. So take a deep breath. Whenever you see a triangle, a right triangle and some sides and maybe an angle, please think right triangle, SOHCAHTOA. So when I look right at this question, I immediately think SOHCAHTOA is going to happen. So I write it down. SOHCAHTOA. Got it. As modeled below, a movie is projected onto a large outdoor screen. The bottom of the 60-foot tall screen is 12 feet from the ground. The projector sits on the ground at a horizontal distance 75 feet from the screen. Okay, fine. Determine and state to the nearest tenth of a degree the measure theta of the projection angle. So we only know how to figure out whole angles like this. So we're going to figure out that whole angle. And then we're going to figure out this little itty bitty piece, and we're going to subtract them to find theta, okay? So I'm going to call this big angle X, and I'm going to call the itty bitty piece Y. So theta is going to be equal to the big angle minus the small angle, if that's helpful to you. So I'm going to be defining two separate things. This is a 4-point question. I shouldn't expect it to be a 1-minute question. So first thing I've got to figure out is which trig function I'm using. So I'm going to start by looking at the big triangle. So the big triangle has an opposite side of 72, right? So the opposite side is 72. And I want to find, oh, and I have the adjacent side, right? I want to find the angle. So as soon as I see opposite and adjacent, I think tangent. So the tangent of the angle, which is, I'm going to call it X, is equal to the opposite over the adjacent. Okay? In order to solve for X, you have to do the opposite of tangent, which is tangent inverse. So X is equal to tangent inverse of 72 over 75. Now it's going to give me a crazy number, so I'm going to go to my calculator. I'm going to press Doc B to clear it out. Tangent inverse, I hate when it does that. I apologize. Escape. What was it? 72 over 75. And I get this crazy number, right? 43 point blah, blah, blah. 43.8308 is what I'm going to write down. 43.8308 ... okay? Then I want to find this little teeny angle, right? Again, I have the opposite and the adjacent. So tangent of little angle y is equal to opposite of 12 over adjacent of 75. And I'm going to do the same math. It's the same scale. It just happens twice. So y is equal to tangent inverse of 12 over 75. Okay, so I'm going to do that in my calculator. And notice I didn't clear it. Oh, sorry. It hates when I do that. So let me see if I can. It doesn't like when I use the pen. I think that's the problem. So tangent inverse of 12 over 75. Let's see if this will work better. It doesn't freak out when I do that. Okay, 9.0903, I guess. 9.0903? 9.0903. Blah, 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 right? Okay, so we decided that theta was the big angle minus the small angle. Here's the good news. I want to show you something here. I want to do 43 minus 9, right? I want to do those numbers. If I arrow up in here and highlight that 43, I can press enter. Then I can press minus and arrow up and click that number and press enter. And I get 34.74 blah blah. So theta equals 34.74. And what? Oh, wait a minute. Didn't a few minutes ago I say something about rounding directions and it could cost you major points? Yeah, here's the second time it could cost you points. Nearest tenth of a degree. You have to round to the nearest tenth. So this is the second time it could cost you a point. This could be the difference between 99 and 100, 84 and 85, 64 and 65. We're talking real deal here. So 34.7 degrees. Beautiful. I'm doing a beautiful job. This is the question you've all been waiting for. I am sure of it. So here we go. Given circle O, chords A, B, and C, D intersect at E. Great. Theorem. If two chords intersect in a circle, the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Great. Prove this theorem by proving a product of AE and EB is equal to the product of CE and ED. When you looked at this, you panicked. What you shouldn't have done is panicked. So what I want you to see is, or at least think about, is when you're given something and you're asked to prove, it's usually two triangles are congruent, two lines intersect to form right angles, something pretty straightforward, okay? You saw this and you panicked, and I think the only thing you maybe wrote down is something about vertical angles. What I want you to think about is what could you put on the paper that makes this like things you've seen before? What makes this look like triangles? And then you're going to be fine. So as soon as you think about that, I'm hoping that your brain says, oh my goodness, all I need to do is draw in these two lines, and then don't I have two triangles, right? And this isn't going to be a congruence proof. It's actually going to be a similarity proof. So usually a similarity proof is angle-angle or side-angle-side similarity. So, okay, well, that makes me feel better. Now that we have triangles, you feel a little bit more confident. So most of you have learned proofs by doing statement, reason, columns, and that's how I'll do this one. So, first thing is to say that you drew those chords. You do have to say the given, so let's, I want to try to do this all in the same thing. So we're given chords A, B, and C, D intersect at E. What can we mark? I just mentioned a second ago vertical angles. I'm going to label them 1 and 2 just because that makes my writing of the proof a little bit easier. And I'm going to write vertical angles because this is sort of my ideas up here. And then I'm looking at these, I'm like, what else do I know about circles and angles? Maybe I'm going to do angle, angle. Maybe I'm going to do side, angle, side. I have no other information. So I'm kind of looking at this and I'm thinking to myself, okay, what about this angle here? This angle at C is the arc BD. So don't we know that angle C, it's an inscribed angle, is half the arc of BD? And follow the other lines to the other triangle. A is also half the arc of BD. Oh, okay. So I'm going to say something about that. 1/2 the arc of BD is equal to the measure of angle C and the measure of angle A, right? So those are going to be the two things I'm going to use in this proof. Circle, oh, okay. So I'm going to go down here and I'm going to do my statements and my reasons. So statements and reasons. My reasons are always a little longer, so I like to make that side a little bit bigger. Okay, number 1 is going to be my given. And I'm just going to write, you know, what was it? Circle O, chords AB, and CD, intersect at E. That's it. Intersect at E. The next thing I did was draw in those lines, okay? So CB and AD are drawn. Sorry, I have to look down instead of looking up. It makes it easier. So 2, you have to just say auxiliary, and I'm going to spell it wrong probably, auxiliary lines can be drawn. Now, if I were you, I would use my graph paper behind this page so I had straight lines and like a writing size, just a piece of advice. Okay, so I drew those lines in, and the next thing I marked were the vertical angles. The measure of angle 1, which I numbered, is equal to the measure of angle 2. Whoops. Oh my goodness, did you see that? I'm a little sleepy. The measure of angle 2. Let's try that again. Okay. Vertical angles are congruent. Okay, now I'm actually going to go back up here. I'm going to label these 3 and 4. Sneaky, huh? I'm going to say the measure of angle 3 is congruent to the measure of angle 4 is equal to 1/2 arc B, was it BD? Right? So, inscribed angles that intercept the same arc are congruent. And actually, so since I said congruent, I want to say just angle, not measure of angle. Sorry. Okay, number 5 then is, don't I have angle, angle? So I can say that triangle, oh, let's see, CBE is similar to triangle ADE by angle, angle similarity. Okay, so that means I can set up a proportion, right? I can say that A to E matches with C to E is equal to, let's see, E to D matches with E to B. If 2 triangles are similar, then their sides are in proportion. Okay, and then the last step is cross products, right? AE times EB is equal to CE times ED. So cross products are equal. Nailed it. So it was a little bit scary when you saw that, I know. Don't forget about drawing in auxiliary lines. I think that's an important lesson here. Okay, last question. Moving on to the last question here. Not a bad question for the last one. I'm not going to lie to you. I was kind of happy to see it, considering everything else that happened. I thought that this was a relatively fair question. I think a lot of you probably earned a lot of points, but I also think you probably got a little, freaked out at points in time. I hope you didn't. Oh my goodness, I don't know what's going on here. Let me try again here to click the right page. It's not letting me do what I want. Okay, there we go. So a snow cone. This was a great question. There's one detail I think some of you missed. So if you were that person, don't freak out. You probably did an okay job. So a snow cone consists of a paper cone completely filled with shaved ice and topped with a hemisphere of shaved ice. Okay, so hemisphere means half of a sphere. So half of a sphere, okay? The inside diameter of both the cone and the hemisphere is 8.3 centimeters. The height of the cone is 10.2. They've labeled all of that in the picture for you. The desired density. We've had a density question here before. You have to know that density is mass over volume. Of the shaved ice is 0.697 grams per centimeters cubed, and the cost per kilogram. So what you had to notice here is that we've got grams and kilograms. Determine and state the cost of the ice needed to make 50 snow cones. Okay, when you think about this, you have to think density equals mass over volume, right? You know you're going to need the volume, so start calculating. The volume of a sphere, or the volume of the hemisphere, right, is half of a sphere, okay? Half of 4/3 pi r cubed. And I'm going to try to squeeze this in here. So 1/2 times 4/3 pi, my radius cubed. I've got to figure that radius out. What is 8.3 divided by 2? Let me clear all this junk out. 8.3, that's a 3, divided by 2, 4.15. I'm going to write that down. Radius equals 4.15. One of their most favorite things to do is to give you diameter and then you need the radius, or they give you the radius and they ask something about the diameter. It's top thing to ask, okay? So 4.15 is the number that goes in here. And I'm just going to type all of that shenanigans into my calculator. So this is the volume of the hemisphere. I'm going to put hemi there. Okay. So control, divide, 1/2. Control, divide, delete, parentheses, control, divide, 4/3, pi, where's that silly pi? Come on, pi, r is 4.15, sorry, my eyes are losing it. I can't see anything. Okay, freeze. 149.69, blah, blah, blah. I'm going to store this. I'm going to do control, store. I'm going to store it for H for hemisphere. Okay, you'll see why in a minute. I don't want to round halfway through a question. I got 149.69348, blah, blah, blah. But I stored it, what did I say, for H? I'm going to use that in a few minutes. Okay, now the volume of the cone. Volume of the cone. Volume of a cone is 1/3 the area of the base, which is a circle, times the height. So 1/3 pi 4.15 squared times 10.2. So let's see if I can get this to play nice with me. Control divide 1/3 pi r 4.15 squared times 10.2. And again, I'm going to store this, okay? Control, store. I'm going to store it for C for cone. How about that? Volume of the cone. 183.9606. Okay. Volume of the cone. 183.96067 dot dot dot. I've stored that for C. Okay, so my total volume is those two things added together. Remember, I showed you on the calculator that you can do that. Volume equals, I can do, I stored them both. H plus C, 333.65. 333.654, 156771. Okay, I'm going to store that, ready for this? I'm going to store that as V for volume. Control store for V. Now I have that in there as volume, so anytime I need to use it, it's going to be in there for me, which is awesome. So this is stored for V. Excellent news. Okay, so the desired density. We know that density is mass over volume, so let's go down here. The desired density is 0.697. D equals M over V. Desired density is 0.697 grams per centimeter cubed equals mass over volume. Okay. Well, I have this volume number, right? That's that 333. So I'm going to do volume times 0.697 grams per centimeter cubed. And that's going to get me my mass. Okay, so let's go to the calculator. And I probably have it in there, but that's okay. 0.697 times, and I stored it for V, is 232.5569, blah, blah, blah. M is equal to 232.55694727. I can store that if I want for M. I can do this every time. I can keep storing. Okay, but this is grams. Okay, we've got to figure out the cost per kilogram. So we've got a problem here, right? Well, if you know this, and I don't know if you do, kilograms are 1,000 grams. Kilo is 1,000. So I'm going to divide this number by 1,000. And I'm only writing it like that because, I don't know, I just felt like it. So the mass is 0.23255694727. I'm going to do that in my calculator. Divide by 1,000. Okay. Awesome. This is kilograms. Okay. The cost per kilogram of ice is $3.83. So I want to figure out what that is, right? So I'm going to multiply by $3.83 times by 3.83 times by 3.83. So 0.8906, 0.8906. I don't have this number written down. 93108, 93108 dot dot dot, and that's dollars, right? Per one snow cone. And I got to figure out how many 50 would be, right? So I've got to multiply by 50. So times 50. 44.53. Let's go down here. $44.50. Oh my goodness, my fives. Sorry. And 53 cents for 50 snow cones. So the big deal was that silly kilogram section right here, that dividing by 1,000. A lot of people miss that. So overall, I hope you did a nice job. I hope this was helpful to you. Come back, ask for things you need. We're here to help.